A pleasant greetings to all. In this video, I am going to explain about line-to-line fault. Figure represents three-phase synchronous generator with a fault occurs on a phase due through an impedance ZF between phases B and C. Assuming the generator is initially on no load, the boundary conditions at fault point are: see, this generator is initially in the no load condition, and the fault occurs between the phases B and C. So this is the fault impedance that is connected in between phases B and C. Next I am going to write the boundary condition. So what is the boundary condition? VB minus VC, that is equal to ZF into IB. Here this is VC and this is VB. So VB minus VC, that is equal to ZF into IB. What is IB plus IC? Here IB is the current flowing direction. This is opposite direction. So IB plus IC equal to 0. And what about IA? IA also 0. These are the boundary conditions. Next I am going to write the symmetrical component of the current. So what is IA0, IA1, IA2? This is a zero sequence component of current. Positive sequence component of current. IA2 is the negative sequence component of current. So 1 by 3, 1, 1, 1, 1 A square, 1 A square A. Here I have to put the value. IA equal to 0. And IB equal to minus IC, or IC equal to minus IB. So put IB and instead of IB put minus IB. From the above equation we find that IA not equal to 0. Here 0, IB minus IB 0. IA1 equal to 1 by 3 into A in minus A square into IB. IA2 also 1 by 3 A square minus A into IB. From the above equation, we note that IA1 equal to minus IA2. Next, I am going to write the unbalanced voltage in terms of symmetrical components of voltage. VA equal to VA0, VA1, VA2. VB equal to VA0 A square into VA1 plus A into VA2. VC equal to VA0 plus A into VA1 plus A square into VA2. VB minus VC. So that is VA0 minus VA0 0. A square minus A into VA1, A minus A square into VA2. Now I am going to take A square minus A, so VA1 minus VA2. But already we have derived the boundary condition for the line-to-line fault. That is VB minus VC equal to ZF into IB, IB plus IC equal to 0 and IA equal to 0. So these are the boundary condition. So VB minus VC equal to, first equation I have to take. In this equation I have to substitute the value. VB minus VC equal to A square minus A into VA1 minus VA2. Already in the previous slide I have derived this. A square minus A into VA1 minus VA2. That is equal to ZF into IB. And IA2 equal to minus IA1. Then in this equation, A square minus A into VA1 minus VA2 have to take VA1. VA1 is what? EA minus Z1 into IA1. What is VA2? VA2 is 0 minus Z2 into IA2. So this is the symmetrical component of the unloaded generator. It is also already I have derived, that is given in the description box. Okay, I have to put the value EA minus Z1 into IA1 plus Z2 into IA2. Here EA minus Z1 into IA1, that is VA1, minus VA2, that is Z2 into IA2. Okay, instead of Z2 into IA2, what I have to substitute? Z minus Z2 into, instead of IA2, that is minus IA1. So minus Z2 into IA1, that is ZF into IB. So A square minus A into EA minus Z1 plus Z2 into IA1, that is ZF into IB. So EA minus Z1 plus Z2 into IA1 is ZB into 3 into IA1. So instead of IB, have to substitute the value 3IA2 divided by A square minus A. So ZB into 3 into minus IA1 divided by A minus A square into A square minus A. This A square minus A in this side. I am going to find out the value IA1. So EA minus Z1 plus Z2 into IA1, that is equal to 3 into IA1 into ZF divided by A square minus A into A minus A square. So I have to expand this term. So A cube minus A power 4 minus A square plus A cube. A cube equal to 1. A power 4 is A cube into A. So minus A square plus 1. So 1, what is 1 minus 1 plus A minus A square equal to 0. From this 1 is equal to minus A square. So 1 plus 1 that is equal to 3. So instead of this denominator part, have to put the value 3. So 3 get cancelled. Finally, I get A is equal to IA1 into Z1 plus Z2 plus ZF. From this IA1 equal to EA divided by Z1 plus Z2 plus ZF. Once again, I have to write the IA1, EA divided by Z1 plus Z2 plus ZF. Next, I am going to draw the sequence network connection for the line-to-line fault. So, two sequence networks are available. One is positive sequence network and sequence impedance Z1, negative sequence impedance Z2. The positive sequence impedance consists of EA and Z1. Here this is Z1 and this is Z2. You have to put the value Z1. Here this is Z1 and this one is Z2. So first draw this positive sequence impedance. Then you have to draw this negative sequence impedance. Then Z1, Z2, ZF3 are connected in series. So all are connected in series. And then the current IA1 and IA2 both are opposing with each other. IA1 equal to minus IA2. You have to draw like this. So connect all this, we'll get the sequence network connection for line to line fault. Thank you. Have a nice day.